Hello, fellow Scratchers! We love making clicker games, but getting our exponentially increasing scores under control is a real pain. Blah, that looks horrible! Well, today we're going to learn how to make big numbers look way cooler in Scratch, in that classic cookie clicker style. That's the magic of engineering notation. Instead of drowning in digits, we just keep the important ones, the most significant digits, and then we whap on the correct unit, be it thousands, millions, billions, and even quindecillions. Yes, that's one, followed by 48 zeros. Wow! And what I really love is that to pull this off, we're going to explore two rarely used Scratch blocks, 10 to the power and log, both of them maths blocks. Put them together, and suddenly we've got the power to tame numbers of any size. So, what are we waiting for? Spin up a new Scratch project, and let's get scratching! So where do we begin? Well, I took the liberty of dropping in this tasty-looking cookie costume. Yummy! But you can use any costume you like. And of course, we're going to need a score variable. So click into the variables, and we'll delete that my variable, and then create a new variable naming it all uppercase score for all sprites. Classic! And there it is represented on the stage. Next up, we'll initialize this variable with a when flag clicked, and set score not to 0, but to 1. This will make it super easy to be able to increment it exponentially. Let me show you what I mean. When sprite clicked, that's when we click this cookie. Then, rather than changing score, we're going to set the score with a multiply block. And then on the left-hand side, we put the score variable itself, and we multiply score by a factor of 10. So when we say a score increases exponentially, what we mean is the score gets larger and larger at a faster and faster rate. So as I click this cookie, we go from 1 to 10 to 100 to 1,000 to 10,000 to 100,000 to 1,000,000 to 10 million and on. Indeed, this is the classic way that scores increase in these clicker games, but it's why we get into trouble in Scratch, because as I click, watch this. We get to 10 million, 100 million, 1,000 billion, who knows how big this number is, and suddenly the numbers are just growing out of control, and they go really ugly all of a sudden. This is scientific notation. You may have seen it on your calculator, and it looks super ugly in a computer game. Who wants a score looking like that? Yuck, yuck, yuck. And the way that we can get this number under control is to work out how long this number is, its magnitude, then chop off the right-hand side and replace it with a nice, neat unit, otherwise known as a suffix. So, how do we find the length of this number? And I expect a lot of you would think, well, how about the length block? Yeah, that's not a bad idea. So to make it really easy to visualize, let's add a forever loop underneath the green flag click block. And inside that, we add a say block. This will keep us up to date from the moment the project begins. And we'll say the length of our score variable. How many letters the score variable is made up of. So let's smash that green flag. And right away, the cookie reports that the score is of length 1. And it's looking very promising as it increases in length as I click, accurately reporting the number of digits in our score. Is this a winning? Oh my gosh. And now you see the flaw in this mechanism. The length of score is only as good as the representation of the score in the first place. So as soon as it switches to scientific notation, then all the bets are off. This only ever reports the length of the visual representation of the variable at this precise moment. 5 letters in 1e plus 23. No, we need the mathematical magnitude of this number, how big it really is. Drum roll please, let me present to you the log block, or its full title, the logarithm block. This awesome little maths function tells us the magnitude of a number, that is the number of tens that it's made up of. So instead of saying the length of score, let's now try the log of score instead, and smash the green flag. So a score of 1 has no tens in it, so we get a log of 0. If we click to bring us up to 10, we've now got 1 10. Click the cookie a second time, and a third, and every time we click it, the score increases by another digit, and the log tells us how many digits there currently are. And even as we plunge into the scientific notation, the log continues to report the length, the magnitude of this number. This is way better than using the length block. And oh look, it's worth noting that the signs notation actually is showing us what the log of the number is at the right hand side. So that's what it's been doing all this time, telling us how long our number is. Also, have you noticed that sometimes the log is reporting whole numbers and at other times it's followed by a dot and 2 zeros? Look at this again. 0, 1, 2, 3.00? What gives? Well, look at this. If I drag out the log score now and click on it to show the true value, it's actually not 3, but 2.9999999999996. And yet, when I use the say block, it reports it as 3.00. Well, that might seem a little bit bizarre, but this is what is known as a floating point error in the mathematics of your computer. The result is oh so close to 3, the true answer, but it didn't quite get there. And this is going to be problematic, as we want to use the floor block to round our numbers down. The number that was oh so close to being 3 is now reported as 2, and when I run the project and click on the cookie, it says 2 when there are 3 zeros, and then it goes straight on to 4, then 5, and then 5 again, skipping 6, going 7, 8. So we really need to fix this floating point issue so we can accurately report the length of our numbers. And the simplest way to do this is to add the tiniest fraction of a number to our score. But rather than using addition, we'll use a multiply block so that it scales with the size of our score. So multiply score by 1.0000001. That's 1.6 zeros and another 1. Then smash the green flag and start clicking that cookie, and now you should see it does not skip a beat, counting from 1 all the way up to, well, how far can I go? Well, I'll leave that as an exercise for you to find out, because I'm super excited to get on with this tutorial. But just before we do, let me quickly tell you about something really cool. Griffpatch Academy. It's my online community where I teach Scratch step by step. We build full games together, test what we've learnt in epic game jams, and connect in a friendly forum full of amazing young creators who love to help each other out. I'm in there too, sharing tips, answering questions, and checking out your projects. So if you're ready to level up your Scratch skills, come join me at Griffpatch Academy. Alright, back to the code. So great, we know the number of digits in our score variable. What we want to do next is map that magnitude to a word, like 1,000, millions, billions, trillions, you name it. So create a new list. And we'll name this suffix. Now, whether you want to declare this for all sprites or for this sprite only is up to you. I like it for all sprites, as then there's only one copy. But if you're planning on backpacking this project for use in other projects, then I'd advise keeping it for this sprite only. Okay. And then we want to manually add our long number names to this list. So click the plus button and then type space and then the word 1,000. Or if you don't want the long format, you could just write K here, which is its symbolic form. Then the next row, we're going to write million. Next up is billion. And then trillion. How many of these do you know? If you do a quick Google, you'll find there's an awful lot. I'll try and remember to leave a list of them under the video. But here's a quick preview of the entire list that I've bothered to type into my list. Okay, so the smart cookies among you will notice that it takes 3 clicks to get the cookie to go to the next suffix. So 3 clicks gives you 1,000, and then another 3 clicks brings us up to the million, 6 zeros. Therefore, we're going to have to divide our log by 3 to map to the suffix list. Before that, let's create a new variable, naming it power of 1,000 for this sprite only, and we'll store this new value in this variable. So set the power of 1,000 to our awesome floor of log maths blocks. And then to convert the magnitude to thousands, we're going to need that division block, but we're dividing the log, not the floor. So drop in the log block into the division, divide by 3, and then pop that back into the floor block. And smash the green flag. Oh, hello cookie. But don't let that distract you from the power of 1,000 variable. Initially 0, it increases to 1 the moment we get to a score of 1,000. And then we reach 1,000,000, it goes to 2. So this is now mapping perfectly to our suffix list. Yeah, we are flying now. So right away into the variable category and find the lists, and we'll use the item of block, say item of suffix, and we'll drop in the power of 1,000, and right away our cookie is reporting billion. But just to be sure, let's start from 1, 10, 100, 1,000, yes! So let's click on 10,000, 100,000, a million! Keep going! Billion! Trillion! And it goes on. Quadrillion, quintillion, sextillion, septillion, octillion, nonillion, decillion, undecillion. Yes, in my opinion, these numbers are very sillion indeed. So, griffpatch, what is the next job we need to do? Well, say I just click this number up to a number of billion, 10 billion. So yeah, I know this number is 10 billion. How do we get our Scratch program to know that too? Well, the trick is to scale this number back by a billion. So divide it by a billion to get how many billions this score is. Let me show you what I mean. First, we'll create a new variable to hold our scaled number, and we'll call it scaled for this sprite only. And then drop in a new set block, setting our scaled variable to the result of dividing our score, that is, dividing 10 billion, by the value a billion. That is 1 with how many zeros? 9 zeros. 1,000 million. Ah, bother. I stopped the project. If I'd kept it running, you'd have seen that result straight away. I'm going to have to click the green flag and then click all the way through back to 10 billion. Okay, there it is. 10 billion. And now you'll see scaled says 10. 10 billion. Because I've divided by 1 billion. And there's 10 billions in 10 billion. Yes, we just need to divide by a number that matches the suffix. But we really don't want to type those numbers in, so how can we calculate it instead? Well, drumroll please. Our next new maths block is the 10 to the power block. And this little gem does exactly what we need. Try feeding it the number 9. That is the number of zeros in a billion. And what's the result? Yes, it's a billion. 1 followed by 9 zeros. Try 3 and you get 1,000. Try 6 and you get a million. So yes, this is exactly what we're after. And we can reuse our power of 1,000. But just remember, when it's 3, it means a billion, which should be 9. So we need to multiply this back up by 3. So we'll do the 10 to the power of the power of 1,000 multiplied by 3. And that should give us back the exact value that we're after. So drop that in on the right-hand side of our set scaled block and smash the green flag again. So we begin with a scaled value of 1, then 10, then 100. Yes, it just mirrors what's in score. But what happens when we reach 1,000? Click. And scale drops back down to 1, and the cookie reports 1,000. 1,000. 10,000. 100,000. 1 million. And the fun keeps going. Billions, trillions, 100 quadrillion. My goodness. Are we there? Have we done it? Well, not so fast there. Because we've been testing this with, well, the simplest possible case. A 1 followed by loads and loads of zeros. But our scores are going to be much more complex than that, so let's try starting off with a score that is not 1. Change the score to 1, 2, 3, 4, 5, 6, 7, 8, 9, and smash the green flag. And this is looking a lot more complicated right off the bat. Our scaled variable's reporting 123.456789 million. And, you know, that actually is correct. It's just retaining a little bit too much precision. When numbers get this big, we're really only interested in the top 3 or 4 digits. And we're still showing 9 of them here. So what would be nice is if we had a way of saying we only want the first 4 digits to be shown. That is, the 4 most significant digits. So how we do this is quite interesting. You may already know that the floor block will take away everything after a decimal place. But we don't want to cut this number off there, we want to cut it off 3 digits to the right. So the clever trick in this case is to shift our number to the left by 3 digits, and then floor it to remove everything after the decimal place, and then shift it back to the right by the same 3 digits. Nice, that is the result we were after. So how do we do it in code? Let's take this a step at a time. To scale this number to 4 significant figures, we need to know how many digits are already to the left of this decimal place. And you may be getting a little bit of deja vu because this is exactly the same problem we had when we tried to work out the length of our original score. And the answer is to use log again. So let's create a new variable to store the number of digits, the digit count of our scaled number, and simply call it digit count for this sprite only. And then we'll set the digit count, again using log. In fact, we might as well just borrow the same maths from our set power of 1000. The difference this time is it's not for the score variable, but for the scaled variable instead. What's more, this is not a power of 1000 this time, but a count of the number of digits. So this is simply a power of 10, so we don't want to divide by 3. We just want the floor of the log of scaled multiplied by 1.0000001. But don't forget this is measured in tens, and our example hasn't even reached 10 yet, so this reports 0. We need to add 1 to this to get the length, including the initial unit. You can see this more clearly if I click the green flag again. Then our number changes to 123.4, and now if we click this floor of, you'll see it reports 2, because we've got 3 numbers. So we need to add 1 to this to show how many digits there are before the decimal place. So drop in an addition block, so we can add 1 to our result. And this should now report 3 digits to the left of the decimal place. Perfect. So this is our digit count. Drop it into our set digit count. And we can just sanity check this by running the project, and each click of the cookie will increase our digit count by 1, and once it gets to 3, it should cycle back down to 1 again. 1, 2, 3, 1, 2, 3, 1, 2, 3. But our goal is to always have 4 digits, so we can get a subtract block. We want 4 digits, so 4 subtract the current digit count, that would be 3. 4 subtract 3 is 1, and that is how many digits we need to shift it to the left. And how do we do that? Well, we multiply it by powers of 10 for each unit we want to move it. So pull out that 10 to the power block once more. And once you've found it right at the bottom there, we can then drop in our 4 subtract digit count. And this is the amount we must multiply our scaled value by before trimming off the insignificant digits. And we're going to need to store this in a variable, so make a new variable, and we'll name this rounding factor. Although strictly we're not using the round block, we're going to be rounding down. That is the floor operator. So set our rounding factor to our new expression, the amount we need to multiply by. Let's just test this by clicking the green flag and see what the rounding factor looks like. It should read off as 1110 and cycle back around. Coolio, we're almost there. So we'll begin by scaling up our scaled variable. Set scaled to the result of multiplying the scaled variable itself with our rounding factor. And this will have a really odd result, because what will happen is when we run the project, you'll see scaled is equal to 1234.56789, 4 digits to the left of the decimal place. And what's really weird is as we click the cookie, this never changes. It always has 4 digits to the left of the decimal place. It's so weird, but it's exactly what we wanted to do, because now we can apply the floor operator to round this number down to the nearest whole number, clearing away all the digits to the right of the decimal place. So yep, we're going to wrap that expression in a floor block. Set scaled to the floor of scaled multiplied by the rounding factor. And straight away you'll see that our scaled value is now a whole number of exactly 4 digits. So all we need to do now is shift it back to the right again. And to do that we need a division block. And we'll divide by the same amount that we multiplied by, rounding factor, having the opposite effect of shifting the units to the right. So drop in the entirety of the floor expression and put it back into scaled. Phew, it is time to smash that green flag and have a look at what we've got. And this is reporting a number of 123.4 million. Click the cookie to times it by 10, and now it says 1.234 billion. With each click, you'll notice the little decimal place starts to move to the right in a number, but we always have our 4 digits of precision. Now, of course, our scripts are actually really quite flexible. We don't have to have 4 digits of precision. We could have 5 digits. Just change this 4 to a 5. And there we have it, 5 digits of precision. And we could have 6, 7, it doesn't matter, whatever you want. But of course, it never shows more precision than you actually have in your number. However, the sweet spot for these cookie clicker style games is usually 3 or 4 digits of precision. And I'll leave it on 4 for now. So guys, what next? Well, I tell you what, let's just spice up our score example a little bit. So rather than starting with this large number, we'll start with the number 12. And then rather than multiplying by 10 each click, we'll multiply by 11. And the reason I do that is that now as I start clicking, you'll see our score, it gets a lot more interesting. It's not got loads and loads of zeros after it anymore. It's now quite a complex number. Nevertheless, our 4 digits of precision are keeping our scaled value nice and clean. And so I think it's about high time we wrap this all together to display a single, fully formatted score. Let's begin by moving this say block to the bottom, which is best achieved by moving the scaled block above the say block. And then we're going to need our join block to join together our awesomely scaled score and the nicely worded suffix. So drop the join back into our say block and pop the scaled on the left-hand side, the item of suffix on the right, and smash that green flag. Here we go, guys. Starting at 12, then 132, then 1.452 thousand, is that right? Kinda looks weird, but if it had been 1k, it would have made a lot more sense to you, wouldn't it? But then we quickly move on to millions, and billions, and trillions, and on it goes. Well, at least it keeps going until we run out of long number names. Kudos to you if you can add a whole bunch more. Seriously, there are just so many number names. Okay, great, this is working exactly as I had hoped. But before we finish, we really should wrap this all up in a custom block to make it all neat and completely reusable. So click with me in the My Blocks and make a new custom block. We'll name it Format Number, and then with an input of number, add a label with the name Precision, and then a final input, and I'll name that Digits to Keep. And we don't need to, but I'm going to click the Run Without Screen Refresh. Okay. And for starters, we'll move everything from within the forever loop into our new custom block definition. We can, of course, then make use of it right away back within our forever loop, and the number that we want to pass in here to be formatted is, of course, our score. Pop that in there. The precision is going to be 4 decimal places, and we want our block to return the new formatted score. So we'll create a variable to return the value in, naming it formatted, and make it for this sprite only. Okay, so let's take another look at our new custom block. And the first job is to plug in these new input variables, starting with number. That's going to replace all of our score variables. The first one here, and the second one here, just 2 of them. So next, the precision, the digits to keep, that replaces our 4 down here. It's much nicer when we can give a name to these things. So lastly, we're no longer going to say the score to the screen. Instead, we return it by setting the formatted variable, set formatted, to the result of the join. And then rather than chucking away this say block, let's move that up into our forever loop once more. Oops, I can see a little cheeky score poking through there, just remove that. Then after formatting our number with the format block, we can report it to the screen by saying formatted. So time for a quick sanity check. Run the project and make sure that clicking that cookie still results in our beautifully formatted numbers. And if all has gone well, then so it should. What's more, now we can easily adjust our precision, we can drop this custom block into any sprite we like, and we'll be well on our way to creating the most epic cookie, taco, anything clickers you can possibly imagine. And that wraps up our adventure into formatting those huge numbers. Pair this with my sprite number counter and you'll have pro-looking scores and stats in no time. If you found this tutorial helpful, make sure to give it a thumbs up and subscribe to the channel so you don't miss any more advanced Scratch tutorials like this one. And if you'd like to go even deeper, building full games with me step by step, joining game jams and getting help from an amazing community of young creators, come join me at Griffpatch Academy. Until next time though, keep experimenting, keep creating, and as always, scratch on, guys!